This is Review Recording 1A for Section 9.3, Unit 9, Chapter 9 of Mathematics 2200. It accompanies Instructional Recording 1A for the same section. We'll be focusing on sketching the graph of a quadratic inequality in two variables. Example 1. Which best represents the graph of 2x squared minus y less than 0? We notice right away that there is no equal sign here, so it must be a dashed boundary. Therefore, that eliminates options A and C. Now all we need is a test value. Let's try one. Let's say, well, 0, 0 is not going to do us much good this time. So let's try something else like 3, 3. So we've got 2 times 3 squared minus 3 is supposed to be less than 0. That gives us 9 times 2, that's 18, minus 3 is less than 0, 15 less than 0, that's false. So 3, 3 is not in the shaded region. So 3, 3 is not in the shaded region in option D. So D is our correct answer. A little note, we had less than 0 in the original inequality, yet we shaded above the graph, above the boundary. That's because when I rearrange, I get negative y less than negative 2x squared. So I'll have to divide both sides by negative 1, but the moment I do that, remember, I've got to change the direction of the inequality. So the inequality becomes y greater than 2x squared. Example 2, sketch the graph of y greater than negative 3x squared plus 6x minus 2. So you notice right away we're going to have a dashed boundary. We are asked to determine the vertex of the boundary and the exact values of the x-intercepts. We'll work on our vertex for the boundary first. Vertex is, well, we'll have to use negative b over 2a unless we want to use completing the square. So we get negative b over 2a equals negative 6 over 2 times negative 3, which is positive 1. Plug that in. To get our y value, we've got negative 3 times 1 squared plus 6 times 1 minus 2. That'll give us negative 3 here, plus 6 will give us 3 minus 2, which is 1. So our vertex will be at 1, 1. Let's plot that right there. Now the x-intercepts of the boundary. Let's do those. The x-intercepts occur when we make negative 3x squared plus 6x minus 2 equal to 0. That one does not factor very nicely, so we're going to have to use our good friend, the quadratic formula. So x equals the negative of our b value, that's negative 6 plus or minus the square root of b squared, that's 6 squared, minus 4 times negative 3 times negative 2, our minus 4ac part, all over 2 times negative 3. We'll have to finish that on the next slide. Therefore, x equals negative 6 plus or minus, under the root sign, we have 36. We have 3 negatives here, so it's going to be a negative result. 4 times 3 is 12 times 2 is 24, all over negative 6. We've got x equals negative 6 plus or minus the square root of 12, all over negative 6. And don't forget the square root of 12 is the same as the square root of 4 times the square root of 3. So we get negative 6 plus or minus 2 root 3 all over negative 6. To simplify that, let's break it up as two cases. A little easier to see it that way. Negative 6 plus 2 root 3 over negative 6. That will give us, when we divide negative 2 into both the top and the bottom, we'll get 3 here, positive 3 here, and negative 1 right there. So we really have 3 minus root 3 over 3. That's the exact value. We'll need to get an approximate value in a moment too. So we also have our other case where we've got the minus right here. We divide -2 into each of the terms again. So -2 into -6 goes 3, and 3 here. But -2 into -1 will give us +1 root 3 here. So we have 3 plus the square root of 3 all over 3. So the exact values of our x-intercepts are 3 minus root 3 over 3 and 0, and 3 plus root 3 over 3 and 0. And the approximate form at approximately 0.420 and 1.580. Let's plot those. So I've got my x-intercepts plotted at their approximate locations. We'd like to have another point or two for accuracy. We can get the y-intercept. It's pretty easy here. Put in 0 for the x, and I'll get -2 for the y. Since that's 1 unit to the left of the vertex, we'll go 1 unit to the right. And now we have 5 points for a reasonable degree of accuracy here. So we dash in our boundary. Something like that. And now we have to take a test point. 0, 0 is a nice one, but it's pretty close to the boundary, so to be sure, I'll use 10, 10. 10 greater than -3 times 10 squared plus 6 times 10 minus 2. Let's see what happens. If that works out to 10 is greater than -242, that's true. So our shaded region should be up this way. Key ideas: a point xy satisfies an inequality in two variables if, when substituted into the inequality, it makes a true statement. An inequality involving a less than or greater than will require a dash boundary. One with an equal sign out requires a solid boundary. And to graph an inequality in two variables, graph the boundary, determine if it should be solid or dashed, use a test point to help determine where the region lies, and shade the appropriate region.